Good morning, fleshlings. Welcome again to the Airships development stream. So we're going to do more things with particles for about a solid hour, then I have to go off and do housework. It's the exciting life of the indie developer. Just gonna tweet about the fact this stream is live. No idea what hashtags I should be using for this. I just picked some random ones. It's always embarrassing when you if you use Twitter, if you use hashtags that no one else uses, and you kind of reveal yourself as being evidently not with the kids. So you don't know which hashtag you're meant to be using for this. I don't. Okay, let's get down to some actual coding. Pressing buttons. There we are. Okay, so in our previous episode we added the ability for particles to get stuck to physics bodies, and we tested this out by having by spawning some crew on the ground and having our land ship stamp on them. So for starters, I'm just going to show what this looks like, and actually there we go, switching to the audio from the actual desktop. Okay. Combat, yeah. So here we're just debug spawning a whole bunch of crew who are just gonna fall onto the ground and stand there and look confused because they don't have AI for doing anything sensible yet. Then we spawn a really big stompy land ship and like some kind of building, and we move to the right. Go slow motion. Oh, someone asked how do you do slow motion. The answer is you press the 1 key. This is not documented anywhere, but pressing 1 while in single player, of course, only slows down the game to 50% speed, which yeah, is pretty useful. So yeah, that pretty much works. We get we get blood stuck to the bottom of the feet, yeah. And if we watch carefully for a while, eventually the blood even drips off again. See? So that just there. That one's gonna drip off in a moment. So yeah, there we go, here was another one. So it then drips the blood off again, which is pretty cool and gruesome. So we've got that pretty much working. Oh yes, as always I have here, or as nearly always, I have in my trusty iPad, which I shall like actually turn on and go into the channel. So if you have any questions or any comments, or you notice I'm doing something stupid, let me know on the chat and I'll reply / do something less stupid. Okay, so we have our to-do list, and our to-do list tells us, okay, so we should use a particle-specific bounce test for stickiness. What we mean by this is that right now we're just literally using the bounding rectangle of all of our physics objects for figuring out whether a particle can stick. But of course our physics objects aren't all rectangular, so that's going to give bad results in a lot of cases. So but that's really boring. So I'm going to prioritize stuff which is cool to work on, right? Because we want to do cool things. I'll do some of the boring stuff off stream instead. So let's add more types of particles that are sticky. That sounds like really the thing to do. So like snow and ground snow and mud and so on. So let's start out by mud. Let's start up by having this concept that if something touches the ground, then particles actually spawn there that kind of represent the mud in the ground or the snow. And so in order to do that, we basically need to add more particles here at the end. So yeah, as I mentioned in the previous stream, this is currently an unholy mess. Particles have so many values that to actually, like, this is you know, this is not really readable, and it's something which should really be moved into a data file at some point. Just move it all into a JSON file, load it in from there, or we'll also make it more moddable and so on. But right now, that's just not a priority, you know. That's just doing that properly will take a day, half a day of work, and right now I'd rather get version 7 out. Okay, so let's have ground mud and ground snow. Okay, and then we define this. It doesn't, okay, mud, it doesn't have a picture type, so it's not a sprite like a piece of smoke or something, it's just a little rectangle. Well, it doesn't take lighting because little bits don't take lighting. Equally, it's not tinted because, again, it doesn't have a picture type. So you can see here that the issue is that because this is literally just a flat list of values, most of them tend to be null or zero or false or something, because they're only relevant under certain circumstances. Okay, so those were all boring. Now stick speed was interesting. Now stick speed for mud or something, mud's pretty sticky, so we want this to be fairly high. With blood spray, we had a stick speed of 1.0. So with mud, we'll do one of 1.5. So mud it's very sticky. Gravity, it should experience gravity normally, just this value. Another slight bug here, I have to multiply the gravity constant by 16 because there's actually a bug which I need to fix in the particle system, which is that the particle system doesn't currently scale its behavior by number of milliseconds. So it's doing everything 16 times too slowly, which means I need to everything's out by a factor of 16 basically. Which is something again that needs fixing, but frankly, because it means taking a lot of these numbers and dividing them by 16, or multiplying them by 16 depending, mostly dividing I think. This is actually a really good idea to do that when I do the export to JSON bit. So again, for now, we'll just deal with this. Okay, now it gets, so we have gravity. How much is this affected by wind? Well, yeah, it's probably affected by wind a little bit, but not that much. Spawn offset is again sort of meaningless here, but we're just going to pick like 12, which is a relatively normal offset of a tile. What else? I have cat hair stuck in my mouth. The speed at which it spawns is just going to be zeros. Mud doesn't really spawn at the speed. Actually, no, it should, because it will kind of splash. Yeah, so actually I was wrong about that. It should spawn at roughly the same speed as, maybe a bit slower than blood. So on the x-axis -1 to 1, on the y-axis we'd expect it to splash upwards really, so -1 to -0.2 or something. Yeah, that actually means we want to decrease this. Again, the idea is that sometimes the mud splatters up a little bit before it actually becomes a decal. Okay, lifespan, I think we pretty much used the one for blood, maybe a bit longer, so say 400 to 800 milliseconds. The size, again something like blood's probably alright, 3 and 2. Let's make it a bit bigger, 4 and 2. So 4 pixels, so it decreases in size at the start of its life, it's 4 pixels across, at the end it's 2 pixels across. And then it just vanishes. Okay, and then finally colors. Now for the colors, we want to use the reference colors from the kind of color scheme. And for mud in particular, well, we can look at the ground and we see mud is really this color. So that's the color it should be. But arguably, for it to be a bit more noticeable, we'll make it this lighter color and then make it shade towards the darker color as it gets older and sort of dries while flying through midair. This is a pointless detail, but whatever, we need to pick some numbers. So yeah. We say this hex color is the start color. We don't have an early color. That's just for stuff like fire that needs to go from white hot to orange and then slowly to red. And the end color, we make this kind of generic brownish kind of background. And finally, now mud tends to not emit light, so let's not make it emit light. Okay, so that's our mud. With the snow, we basically want to have the same, almost the same behavior. So we're just going to copy these values, adjust them a little bit. And what we want to adjust is, okay, because it's snow, it's a lot lighter, so it's going to be much more affected by wind. It's also going to be a bit less affected by gravity, like so. The stick speed we're going to leave. We leave all of that, we leave the starting speed and so on. But obviously snow it tends to be white. So we'll just make it white. Okay, so we've got 2 new particles defined, and now we need to actually spawn those particles on the ground when there's some kind of impact, both by feet or also by ships or whatever. And so I guess really the place where we want to do this is in land formation, because here we should already have a piece of logic that basically tells us there's already a piece of logic that produces dust particles at high impact speeds, I believe. Let's just look this up. It's gonna be it's even called dust. Now evidently it's not in there, or maybe we removed it at some point, foolishly. No, there it is. Okay, so it's actually in the logic of airships colliding with the ground, which is slightly backwards. Never mind. So let's add another little bit of logic to land formations, that when they get collided with, they can emit a bunch of particle types. And to do that, we actually want to go into time of day. So time of day is basically the value that tells us, is it raining, is it dawn, is it dusk, whatever. So it's really time of day and weather and so on, everything together. Yeah, and then it references a weather effect. It's actually the weather effect that we want, because in the weather effect we can now put in what kind of particles the ground emits when it's stepped on. Yeah, and actually I'm gonna just make a distinction here in between whether the ground is dry or wet. Because you want a lot more splashiness when the ground is. So we'll go for ground, modern ground soil. So the difference with mud is that it's waterier, which means it it spritzes more basically. And it starts out already being quite dark because it's wet. And the particle size is smaller, right? So it's not like bits of earth, it's more a splash of mud. Let's try something like that. And then in weather effect, we can now specify this new piece of information where we can say public final particle.type ground impact particle, and the number of them, so we can control that as well. That's going to be scaled by something, so I'm just pretty much going to make up some numbers. Okay. Okay, so if there's no weather at all, well, none is really it's a bit of a weird way of putting it. None just means it's, it's sunny. So in that case, it's particle.type ground soil, and probably not that much. So it's going to say 3 as an arbitrary number here. Equally, same with dawn and dusk, night. But now here in the rain, or in the fog, yeah, okay, in the rain, it's now ground mud, and we're gonna make it produce a lot more particles. Equally in the storm, and in the fog, I think we'll use mud too, but fewer. And finally in the snow, we'll use snow, of course, and like something in between. Okay, so we've now defined the data for this new effect. Now we need to just actually do it. I think we want to do this in land formation, in the collide with function, right? That probably works. So we have all of these overlaps, which are the coordinates of the tiles, and we're gonna look at, or we're gonna see if they should produce splashing. So now we need to take this in a bit because we now want to produce little bits of splashy. Well, arguably no. I mean, the impact needs to be hard enough that at least 1 point of damage gets caused. I think that's reasonable. So really, really gentle bumps don't produce anything. So if LBT dot, okay, so for what types should it be? Really for grass and for soil, yeah. If LBT equals grass or LBT is soil. And we need it to make sure that it's at the top. So, and the GY, the grid Y coordinate is 0, or grid GY minus 1 GX dot, well, it's not solid, so this only, it should only spawn these particles if it's actually at the top of the grid. So like if you bump against something from the side, it shouldn't be producing splashy particles at the top of it. So if all of this is given, then we do for int n be actually it's going to be combat dot time of day dot weather dot dot effect dot non-grounding particles, and we create a new particle. That's roughly what we want. So combat dot particles dot add. Let's just do particle dot type t equals day effect ground impact particle. If you don't have to write this out each time. To create a new particle. Should be of type t. Then we have x, y, dx, dy. So x is the absolute x of the land block plus the grid x times, that's the grid size constant, plus anywhere within that block horizontally. Vertically it should be just above the ground. The dx should be t dot min dx plus, so anim r is the animation random, so it's the source of random numbers that gets used whenever some purely visual effect is needs a random number, so anything that doesn't have to synchronize across networking. So the point is that like it's not going to affect the gameplay where the particles go exactly. So it's a good idea to not bother going for detailed calculations and going for a synchronized random function and so on. You can be a bit lazier with this stuff, because as long as it looks fine on both sides of the multiplayer combat, you know, that's enough. Okay, so in a purely theoretical world, this now works. If anything collides with a land formation, and it collides hard enough to do at least one damage point, and it's grass or soil it's colliding against, then we spawn a bunch of mud or snow or soil particles and send those out. Stupid question. Did I make them? Yeah, I did make them sticky. Okay, let's try this. Aforementioned tea. Okay. That doesn't really matter. We just want, yeah, so something rainy like this is actually alright. Okay, so that, if you saw that fundamentally worked. There was a quick splash as this building actually touched down. Okay, and this quote unquote works too. It's just a minor detail about how it's never stopping. That's not quite right, but you can see the general principle of the thing, right? So it's also spawning too high up. Okay, right. Try again. So what do we need to do? We need to spawn less high up. Let's just spawn them right here, and we're going to have to introduce some kind of arbitrary value for the amount of damage. And hopefully we can get that within the correct range, because ideally we'd like even relatively small land ships to make splish splashes when they walk, but we'd like large land ships to not create a constant fountain of particles when they're just standing there. So now it's no longer making a constant fountain, but it's also completely failing to produce any particles at all on impact. You know, let's just pick some numbers and keep on trying experimentally if we can arrive at the right value. I know it has to be somewhere in between 0 and 5. Let's try 1, which pretty much means have you done any significant damage? That might be the right value. We'll see. It's no longer fountaining. Yeah, that's actually quite good. So they're too fast, by far, I think. They're also not getting stuck on the feet, which is unfortunate. So let's just fix that up. So those were mud particles, and they were going way too fast. So let's slow everything down a bit. Huh? Okay. But it's heading in the right direction. Again, forgive the terrible frames per second. I'm pretty certain this is just OBS. Okay, so now it's not doing it. Why? Probably because the boundary is just a bit iffy. Or maybe because the snow stuff doesn't work. Let's try it with... Okay, there was a splash there. I think that bound is not already a little bit too high. Okay, so one big question now is, if we put a large land ship down, is it gonna fountain, right? Basically, we have a bit of a problem if the impact strength of the of a large land ship resting is bigger than the impact strength of a small one walking. No, not really. But look, even now it's still only splashing sometimes. So we have to calibrate the that boundary a bit more carefully yet. So damage is greater than 1 might already be too high a hurdle. But we don't care about the number of overlaps, really. We really just care about the hit energy. So if the hit energy is... oh, it's greater than 0.5. Pick a number, pick any number, let's see what 0.5 does. Because we don't really care whether the impact's been like buffered by a whole bunch of tiles simultaneously, or if it's just against that tile. Right now we just care about like a little bit of snow or mud or something on that particular tile, and if that gets smacked into at high enough speed to produce some spray. Okay, so that's again clearly the wrong boundary. Let's try that again. Oh yeah, I was going to tell you about the Napoleon story. I actually wanted to look this up and then forgot, but I'll see if I can remember it more or less correctly. So, right, so Napoleon got exiled twice, right? He first got put onto Elba and kind of told to behave, and he really didn't behave in the sense that he came back and tried to basically reconquer all of Europe. People got fairly pissed off with him for trying to do that, and so they put him on St. Helena instead, which is like a little island like in the middle of the ocean. The idea being that like the British Navy could look, yeah, oh, that's good. That's nice. The British Navy could kind of would have a much easier time actually making sure he didn't just run away from there and try to conquer Europe like a third time. But of course, there were lots of people who, very much believed that actually this Napoleon stuff was totally amazing and great, and wanted him back. And one of the more outlandish plans hatched to actually get him back was to construct a pair of submarines to approach St. Helena, kind of beneath the waves, out of view of the British Navy and any onlookers. I think there was a garrison stationed there as well. And the idea was that the submarines would, I think, come up to shore. One of them would like send a kind of crack team of infiltrators up to the house where Napoleon was being held prisoner, and would then get him and lower him down a nearby cliff on a kind of winch into the waiting second submarine that would then head off. And yeah, I mean, this was something of a serious plan. There were plans for the submarine. They were looking for people to fund this undertaking and so on. It probably would never have happened anyway. Well, it's also just practically cut short because Napoleon then proceeded to die. So that particular craziness never got put into action. But can you imagine, like, let's go, like, you have to understand this was like, what, 1820 something? Submarines were like weird, crazy high-tech stuff. Yeah, that pretty much works. Yeah, see, now it has a lovely combination of mud and blood stuck to its feet. So how about a big land ship? Does this produce fountains? Because I feel like I might want to make it just a tiny bit more sensitive. But that might be a bad idea. Where is it? Here. Yep, no fountains. Have I changed something to do with the leg positioning? Yes, like I didn't really do all of that on the stream because it was mostly a really huge amount of just trying to fiddle with stuff. But basically, yeah, I've added a bunch more logic to the legs. So the legs, no, it has improved. So like what the legs now do is they when they're trying to find a place to put the foot, it now considers alternate X positions to see if it can find a better place to put down its foot than the kind of default one. I've also put in some constraints that a lot of the movements that were previously kind of instantaneous teleportations now actually they're still fast, but they go over a series of frames, so that helps. And oh yeah, and the other thing which I did was that I made that's probably the main thing actually, the movement of the legs is now faster or slower depending on the movement speed of the ship, which means that I could give it a longer stride length and still have it behave sensibly. And that means that a lot of the ships now move the legs move much more slowly, which is good because yeah, it makes it look less more like kind of stomp, 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 stomp. And anyway, hi Slimy. So I'm just gonna make a slight variation in the exact Y offset where they spawn. And I'm just gonna say 0.7 is enough. Yeah, 0.75. Okay. So it now spawns these particles. Cool. So that pretty much works. Got more sticky particles. So let's just try this out on an airship actually. I just want to see if it looks alright when you like ground an airship. It should also get some splash into the ship. And then we will work on, I think, soot particles. So there's like some blackened stuff on the sides of ships where they get hit and stuff like that. Anything? Airship? Oh dear, okay, that was bad. Now it's continually emitting them. So hit energy should clearly be at least 1. Otherwise bad stuff. Yeah, this is a bit difficult. Okay, now I'm gonna say should probably scale it by overlaps. And then we can just mix it up to 2.5 or something. Let's try that. Let's try this again. So let's put in kind of everything. Let's pick a weather where we can see it better, like snow or mud, rain. Yep. Okay, small land ship, large land ship, airship, and building. Okay, so nothing's going to be fountaining, that's good. Now large land ship, when you move, you produce ground splashes. So that's as it should be. Well, that's a bit buggy. But I think those are ground splashes. They're all blood. Okay, small land ship. Move. Okay, so you don't produce ground splashes. That suggests we need to move the boundary down a bit. Okay, you do, but only like when you do a really heavy movement. Finally, if we ground, interesting, the ground ship button seems to not do anything today, so let's just manually ground it. Yes, there were some splashes, along with some breakage. There were also splashes. So again, no. Yeah, that's pretty good. So can we just just want to see if I can get that perfect balance where basically nothing perma-sprays from just the weight, but stuff splashes nicely. If I can't get that to work, I'm just going to hack it by passing in the actual collision velocity as opposed to just the energy, and then use that. Okay, so far no fountain. Still sort of no snow here. Yeah, that one gets snow. Okay, lower that boundary further. HMS Belial to test if land ships don't produce a perma fountain. Okay, so little ship. What's the purpose of the land ship with the call excess? Actually, that was just a test to see how much weight the feed can support. So the coal stuff was just an easy way of generating extra weight. Getting there, still a bit too okay, so that should do it. Yeah, whatever. Okay, no perma-spraying. You. Still doesn't seem to be enough. Okay, 0.7, right? That should definitely be enough. It's probably too much, never mind. Let's see. Okay, no fountaining at least. Now you, young sir, will hopefully produce nice stompy stumps of snow. Well, a lot of the time anyway. It's a bit of an unexpected behavior. But no, that's okay now. You of course produce lots of snow. Ooh dear, okay, so that's too sensitive. That is too sensitive. See? Now we have a fountaining thing going on here. Okay, now we know. Let's just leave it at 1.0. Okay, no, that's alright. We'll leave it at that for now. These big stompy land ships and land ships that like fall down and so on will produce this kind of mild and so on fountains. Yeah, I'm gonna actually commit all of this stuff to Git. And then I'm probably gonna call it a stream for now, because it has been, again, nearly an hour. Trying to stick with kind of bite-sized hour segments, and I do have to go and do useful things now. But yeah, next time we'll see. I might do some more graphics. I might continue working on the sticky particle stuff. Might work on that off stream or something. And yeah, as usual, if you have feedback or suggestions, I'm, still trying to figure out how this whole Twitch streaming thing actually works. So if I'm doing something that's really annoying or confusing or something, or if there's something you'd like me to do, not do, whatever, do let me know in the chat or in the YouTube comments or something, and I will strive to improve that. For now, I thank you for watching once again, and bid you goodbye.